Hi everybody, welcome back to our YouTube channel. In today's video, I am going to solve today's Leetcode problem. Today's Leetcode problem is 28, that is subsets. So let's try to understand the problem statement, and after that we will see the approach for solving this problem. So we have given an integer array nums of unique element. Okay, return all possible subset, that is the power set. Also subset is also known as power set. The solution set must not contain duplicate subset. Return the solution in any order. So let's try to understand. We have given in nums array of integer. Here if I see this example, so this is the array. So we have to return all the subset of this array. Subset is like if I pick or not pick. See, subset is null when none of the elements should be picked, and subset is one when subset is one when one is picked and both 2 3 is not picked. Subset is 2 when one is not picked, 2 is picked and 3 is not picked. Subset is 1 2 when one is picked, 2 is picked, 3 is not picked. Subset is 3 when one is not picked, 2 is not picked, 3 is picked. Subset is 1 3 when 1 is picked, 3 is picked, 2 is not picked. Subset is 2 3 when 1 is not picked, 2 is picked, 3 is picked. Subset is 1 2 3 when all the elements should be picked. Okay, so this is the problem statement, and if I consider this example, then we have given only one element. So subset are either empty subset or containing one, that is zero element. So let's try to understand this problem statement in the whiteboard for better understanding. So in this example, we have given nums that's contain 1 to 3. So let's try to understand. So in the previous example, we have given 1 2 3. Okay, so we have to print all the subset. So if I wanted to print all the subsets, then every element has two choices, either pick or not pick. This element also two choices, that pick or not pick. This element also has two choices, that pick or not pick. Okay, so basically this problem is solved using two approach, that is power set as well as a recursive approach. So in this video I am going to solve the recursive approach of this problem. Okay, so see, every element has two choices, that is pick or not pick. So see, if I not pick any element, so if I not pick not pick, then our subset will be empty set. And if I pick only one element, then both 2 and 3 are not picked, then our subset is 1. And if I pick only two elements, then our subset is 2. Like that, all the subset will be generated, as I have discussed previously. So let's try to understand the approach of solving this problem. Okay, so whenever in any question there is a pick or not pick, then if we use the recursive approach, then let's try to draw the recursive tree, that how we will solve this problem. So for solving this problem, let's take a function that takes the index is equal to 0. Let's take index is equal to 0, and also take a data structure that store the element at that particular element. So every element has two choices. First choice is either pick, or second choice is not pick. If I pick that element, then after picking that element, move to the next element. See here, if I write the index, then 0 1 2 3, and the in size of the vector is 3. Okay, so if I pick the element, then we have to move to next index, that is 1, and in the data structure we have to store the index at 0. So at the index 0 we have 1. Okay, and see, in the recursive function what happens, we complete first left call, and after that we complete the right call. So let's try to first complete the left call. Okay, so after 1 1, then again this index also has two choices, either pick or not pick. Okay, if I pick this element, then be moved to the second index, and also in the data structure be contain one that is at 0 index and two that is at 1 index. Okay, and after that be reach at index 2, and again the left call occur. This index also is two choices that either pick or not pick. These are the two choices. If I pick the element at index 2, then be reach to at index 3, and our vector contains, that is data structure contain 1 2 and 3. Okay, these things happen. So when I reach the 3, that is the outer bound of the array, then at that condition be return this vector, because see at this position we get one subset that is 1 2 3. We get this subset, and after that be return. While returning, we pop the last element from the data structure. We pop 3, then we have 2 and 1. So for this recursion call, we completed the left recursion call, then again move to the right recursion call. If I not pick the second index element, then we move to the 3 index and our vector contains 1 2. So whenever we reach out of the bound, that is whenever index is greater equal to 3, that is n, then we have to return whatever the element stored in the vector. So at this condition we have to get 1 2, and after that we return from there. Okay, for this recursion call we have completed left call as well as right call. So after returning from here, we remove whatever the element at the top of the vector. Okay, so whenever we remove that vector, then we reach at this position. Okay, so now vector contain 1, and now we are at index 1. So if we are at index 1, then we have completed one call, that is pick. If I not pick, then what happens? We move to index and we get a vector that containing only one element, that is at index 0. Okay, so this function call also has two choices, that it pick the second element or not pick. If I pick the second index element, then of our I move to the next index, that is 3, and our data structure contain 1 and 2, because I pick the second index element, second index element, that is 3. So our data structure contain 1 and 3. Okay, so first this function call will be completed. So we have to reach last index, that is out of bound. Then at that condition we push this vector in another vector, and after that we return from here. While returning, we remove the pop element. So we remove that things, and after that our vector contain this much. And if I not pick the second index element, then we have to reach the third index element, and our data structure contain only one element, that is 1. So if I reach the 3 index, then whatever the element is stored in the data structure, print that data structure element, and after that be returned. Okay, so for this function call we have completed left function call as well as right function call. Then we have to return from this position. Again, while returning from this position, we remove the top element in the vector. So I have completed these call, that is 1 2 3 4 for the left. For 0 index we have completed this thing, and now we have to complete the right call. So for completing the right call, let's see what happens. So as I have discussed that we have completed the left call for 0 and empty data structure, and when I not pick the 0 index, then let's be right here, because see, yeah, so not pick. If I not pick the 0 element, then we move to the second, that is 1 index, and our data structure is empty. Okay, then we have also two choices at 1 index, either pick the first element or not pick. Okay, if I pick the first index element, then our first element is 2. So our data structure, we move to the next element, and our data structure contain the 2, that is first element index. Okay, then again call the left function call completed first, then again pick or not pick, two choices. If I pick the second index element, then we move to the third element index, and after that our data structure contain 2, and whatever the element and second index, that is 3. Okay, whenever we reach the third index, that is out of the bond, then we have to print that vector, that data structure, and after that we return back. So 2 3 will be printed, then we have to return from that index. So while returning, we pop the last element and we come to this position, then we again call to the right call, complete the right call. So right call is complete at 2 index, and we are not going to include the second index. So we move to the third index element, and our vector contain 2. Whenever we reach the 3 index, then we print. So this 2 should be printed. Okay, again we return from this thing, and while returning we pop this element, again we reach at this position. So for at 1, if I not pick the first element, then we have choices like we move to the second index and our vector should be empty. So at second index we have also two choices. We have two choices, either pick second element or not pick. If I pick the second element, then our vector should be reach to the next index, that is third, and our vector should be, if I pick the second index, then our vector should be 3. Okay, and whenever we reach the last index, then whatever the element contained in the vector data structure, we print that things, and after that we return from this position. While returning, we pop these things, and one another choice, that is not pick the second element. If not pick, then we reach to the third element, and after data structure is empty, data structure will be empty. So at that position we also print the empty subset, and after that we return the call here. After return, so this recursive function will be completed, and we get this much of subset, and these are the subset of this array. So I hope you all understand the problem statement and also the approach of solving this problem. So let's summarize that things. So in the recursive function, we take parameter like index, that is started with 0 index, and after that let's take a data structure and also contain the nums, that is the given array. So we have two choices for every index, either pick or not pick. If I pick the element, then our data structure will be contain that element, index data structure contain that element, and after that nums will be same. And while returning, one thing sure, that we have to pop the top element from the data structure, then again we call to the right function call. So like that you do all thing, and whenever the index hit to the auto point, that is here in, if n greater equal to 3, because we have only 0 1 2 index, and whenever we reach greater equal to 3, then we have return at the at that position, and after that whatever the element containing in the top of the data structure, we also pop data structure before returning to this function call. So this is the approach of solving this problem. So let's try to see the code for better understanding. So see, whatever I have discussed, I will write the code simply. So see, first of all, we contain take a global of 2D answer array vector, because we have to return the 2D vector array. Okay, so for this we take globally. Okay, so first find the size of the nums array, and after that we take a temp vector, and we call the helper function, takes the index that is 0, and also temp vector, and also the nums this one. Okay, so this is the helper function. So what happens, as I have discussed, that whenever index is greater equal to nums dot size, in this condition the n is equal to 3, then whenever the index hit greater equal to 3, then at that condition whatever the element stored it in the temp data structure, push it in the answer data structure, and after that we return from that call. So this is our base case, and we have two choices, either pick or not pick. Okay, if I pick that element, then push it in data structure and call to the next index, okay? And after completing this index, then while returning back, as I have discussed, that pop the element whatever in the top of the data structure, then call for the right call, okay? So this is considered as the left call, and this is considered as the right call, okay? This is right code, okay? And this is the step where we pop the remove the top of the data structure element. So this is our code. I hope you all understand the code as well. So let's try to submit the code and see what happens, okay? So let's submit. So it will be correct for this test cases, and if you try to submit for all the test cases, then you will get the correct answer. So hope you all understand this problem statement. So thank you for watching the video. See you in the next video.